is also available. That information is also available. So if you want to define the tectonic framework, if you want to learn about the tectonic framework of India, these are the components that we have to understand how they interacted, what is their own geodynamic history, how these different lithologic associations can be reconstructed. The geology can be reconstructed using these records of lithology, structure, the tectonic deformation. All these things is nothing but the tectonic framework of India. And generally we keep separate Himalaya. Himalaya is a special, we have to give a special emphasis to Himalaya. So we will see today the other part of the tectonic framework of India. The growth of the continental crust of the Indian plate that occurred during Archean with separate nuclei. What are those nuclei that we will see? Now, whatever we have seen, the craton, nuclei, shield, platform, that we have to apply to the Indian plate. What are those things? So that early Archean kind of India, we can say proto-continent. And so it remained continent for longer time. Several episodes of oceanic sedimentation are there, but overall it remained as a positive crustal mass. And the nuclear regions also, nuclear means nucleus of that particular craton, they also remain intact. They did not fragment. Rather, the cratons with this nucleus, they accreted, they joined together to form the bigger continent. And also how this continental crust was grown not only by accretion, but also by subcrustal addition of new material from the mantle. And making a stable continental mass. So now the earliest part of this protocontinent we can define by nucleus, around which nucleus means a hypothetical region around which the crustal mass has grown. Nucleus means something is not developing from the nucleus, but the oldest part of that craton. Oldest part we can define by rocks as well as dating of these rocks. So what are those nucleus by which the Indian protocontinent was developed? These are 5 nucleus. 5 nuclei. One is the Karnataka nucleus. So in this case, Karnataka nucleus, the status of Western and Eastern Dharwar craton is included in this Karnataka nucleus. But later on we will see we need to separate Western and Eastern Dharwar craton if you want to discuss in detail. Second is Bastar nucleus. Sometimes it is called Bastar Bhandara nucleus also, but mostly Bastar nucleus. Another is Singhbhum nucleus. Fourth is Bhilwara nucleus of Aravalli protocontinent. And fifth is Bundelkhand nucleus. So these are the regions to find the oldest rocks over the Indian plate. Dating of this nucleus is still in preliminary stage. Lot of dates are not available, but we definitely know they are the oldest rocks. Considering their mineralogy, considering their association with other rocks, they are oldest rocks. So the plate interior is developed by this crustal mass around this nucleus. One is Dharwar Keton, Bastar Keton. Dharwar and Bastar Keton is separated by Godavari Rift. Now there is some vagueness about the Godavari, how Godavari Rift can be the distinction between Dharwar Keton and Bastar Keton, that I will come to it later on, because Godavari Rift is not Archean, it is developed in Proterozoic. Similarly, Mahanadi Rift. Similarly, the Narmada Son Rift. The difference between Godavari Rift, Mahanadi Rift and Narmada Son Rift has to be understood in order to discuss the accretion of these different cretons. The Son Narmada Rift is in fact associated with the mobile belt, Central Indian Shear Zone. On the other hand, Godavari Rift and Mahanadi Rift, they are not associated with a mobile belt. Mahanadi, some records are there that we will see. Otherwise, the Godavari Rift is not associated with a mobile belt. And the southern part is called granulatic terrain. It has a very good boundary with the Dharwar Creton. What is that boundary? We generally call this granulatic belt as the mobile belt. Granulatic terrain as mobile part of mobile belt. The Pandian mobile belt, Eastern Ghat mobile belt, all these are associated. So the boundary between Dharwar Keton and this mobile belt is metamorphic boundary. Relatively low grade metamorphism is separated by high grade metamorphism, medium to high grade metamorphism. Then large part of Dharwar Keton is covered by Deccan Trap. And this, because of that, we do not have complete knowledge about the Dharwar Keton. Whatever exposed is very nicely explored by geologists. Detailed studies are there in Dharwar Keton, but lot of it is covered with Deccan Trap. Deccan Trap being a high density rock, several geophysical surveys are not successful to understand the nature of the Dharwar Keton below Deccan Traps. Yeah, and again, there are structural trends developed that also indicate the presence of the given Creton. Now this is Dharwar Creton. So if you look at the dips and strike, cystosity and all these things, you will see the trend matches with the Dharwar Creton. Similarly, to some extent Bastar Creton, to some extent with the Singhbum Creton, but Dharwar Creton is very ideal. Ideally, you can see the structural trends demarcating the Dharwar Creton. Now, the surface geology has to be determined, has to be confirmed with the subsurface structures also. How the Creton is configured subsurface, that is also very important. That can be done by geophysical surveys. And over the Indian plate, several geophysical transects were done. So these geophysical transects may be gravity, magnetic, magnetotelluric, and many other methods. But most important is the seismic